In this case, our equation involve radical, and the radical is isolated. In other words, the radical is all by itself in one side of the equation. Now, this question could be represented to you as square root of 5x minus 14, and then you could have minus 4 here, like that, equal to minus x. So this is an equivalent equation, except this one here, as you can see, the radical is not isolated, it's negative 4 is next to it. So if they give you the problem like this, then you need to isolate it, but you have to add 4 to both sides of the equation like that. So you get to isolate radical, but sometimes cannot isolate the radical. You have to do this process twice. But everybody's what I'm talking about here, right? So in this case, this is already isolated, so I don't have to worry about the first step. The next step is after you isolate them, you square both sides. So you square the left-hand side. The reason we square it to eliminate the radical, because radical is like power of 1/2. You square this side, you square this side. Now, one thing is very important to remember here is you're squaring both sides, not each term. I've seen some students by mistake they square 4 or square x and they square this thing. They eliminate the radical. Now you move on. You need to square each side. So when you square each side, then you have to know the property that we had, a minus b squared. That is the same as a squared minus 2ab plus b squared. You have to use this to expand this binomial. So on the left-hand side, we eliminate the radical. On the right-hand side, we get 4 squared, which is 16, minus 2ab, would be 2 times 4 is 8 times x would be 8x, plus the last term square, using this property to expand what you have on the right-hand side. The next step is to move everything to one side of the equation and then solve for x. So let's move everything to the right since our x squared is already in the right. I'm going to write it in order too. I'm going to write x squared first and then put minus 8x. Then I'm going to subtract 5x from both of the equation. So all x goes to the right. And then I have 16 here. I need to move the 14 to the other side. So I'm going to then add 14 to both sides of the equation. So I'm forcing to have everything goes to one side of the equation like that. So now I get to write this as a standard form, second order equation, x squared, and then I'm going to combine all the x's together, minus 8x minus 8x minus 5x. So both of these are minus, so we need to add up. So like you have 8 plus 5, they give you minus 13x, so you get minus 13x here. And then here we need to add the constant. You have 16 plus 14, they give you 30 plus 30 equal to 0. So this is what you need to solve for x. If this is not factorable, you need to use quadratic formula, but in this case it is factorable. You open 2 parentheses, you put x and x here. You look for 2 numbers. When you multiply them together, you get 30. You add them up, you get minus 13. Since your final exam is going to be multiple choice, so these are going to kind of help you with the factoring one. So 3 and 10 looks like is what you need. 3 and 10. You want to see if you can add them up to negative 13. Both has to be minus. And don't forget, you also have to check, make sure still the product of these are here. Negative 3 times negative 10 is plus 30, so everything is there. So now I'm going to let x minus 3 equal to 0, so x equal to 3, or x minus 10 equal to 0, so that will give me x is equal to 10. Now you also have to check the answers if both of these answers make sense. Sometimes it doesn't. So let's check 3. So if I substitute, let's check 3. See if it is equal to 3 is a real solution. So if I go ahead and substitute for each x3 and see if it's going to add up to what I have on the right hand side. So here will be 4 minus 3. So on the right hand, 4 minus 3 would be equal to 1. And I have to see if this is going to be equal to 1. This would be 3 times 5 is 15 minus 14. 15 minus 14 would be 1. Square root of 1 would be 1. Yes, this is good. This one checks out. Let's also check x is equal to 10. So you would substitute for each x 10 and see if it's going to add up to what we have on the right hand side, 4 minus 10. So 4 minus 10, you get negative 6 here. And this gives me 50. 5 times 10 would be 50 minus 14. So you get 50 minus 14, that will give you 36. Square root of 36 is 6. So it looks like it shows 6 is equal to minus, so that doesn't check out. So 10 is not a solution, but 3 it is. So it looks like this particular example, D would be the correct choice. Okay, here we want to simplify this, and it says at the top rationalize. Rationalize means it says rationalize the denominator. So that should be a hint to you how to get started with this. Rationalizing the denominator means you eliminate the radical at the bottom of the fraction. And you need to remember, if you only have one radical at the bottom of the fraction, then you multiply by itself and the radical is gone. So if I didn't have this radical s here, then I multiply the top and bottom by radical z, then radical z times radical z would be z. Would be radical z squared or just z, we eliminate the radical. But if two terms, you have to multiply by conjugate. The word is conjugate. So if I have radical z plus radical s, you multiply this by its conjugate. Conjugate of a plus b is a minus b. So I need to multiply top and bottom of fraction by conjugate of this, which is radical z minus radical s. So let's do that. Here I have radical z over radical z plus radical s. So if I multiply by conjugate, this would be radical z minus radical s, radical z minus radical s. So you multiply this really by 1. When you multiply any binomial by conjugate, you get difference of square, if you recall. So it would be, first term square would be z squared minus radical s squared. Now this square would eliminate the radical. So this would be z minus s. Because why? Because when you multiply the two closest term and furthest term, that adds up to 0. So the product of a binomial times its conjugate would be the first term squared, which is z squared, minus the second term squared. So this is how you eliminate the radical at the bottom of the fraction. You get z minus s at the bottom of the fraction. Now at the top of the fraction, you simply have to distribute here. You may or may not get radical. Most likely you're going to get radical at the top. Here you get radical z times radical z would be radical z squared, which is z, minus radical z times radical s would be radical z s. So that's what you're at the top of the fraction. You get z minus radical zs at the top of the fraction over z minus s. I did rationalize this. I don't have any radical at the bottom of the fraction, and looks like one of these should be a correct answer. Z minus s at the bottom, that's the one, and then you get z minus. You have to be very careful with this. Look like this, the last one is matching our solution right there. D is the correct answer there. Right there is D. Okay, here we have an equation, x times x minus 4 equal to 7. It says use quadratic formula to solve for that. So this is a hint. Quadratic formula would, if I get the problem, looks like ax squared plus bx plus c is equal to 0. If I get it to this form, then I can solve for x would be minus b plus and minus square root of b squared minus 4ac divided by 2a. So that is the quadratic formula. You need to remember that. And for this, I need to first get it into this form first, which is not in this case. So I need to distribute. If I go ahead and distribute the x, I would get x to the power of 2 minus 4x, and this 7, I can move it to the left by subtracting 7 from both sides of the equation. So I got it into the standard form right like that now. So the rest is pretty simple. My a is the coefficient of x squared, which is 1. My b is minus 4. And my c is negative 7. So all I have to do now is just substitute these values into this formula. I only have, okay, minus b. So we do minus b is minus 4. So I have to be very careful with the sign, you guys. Minus minus would be plus. Plus and minus square root of b squared, and you take negative 4 and you square it, minus 4 times a is 1, and c is negative 7 over 2 times 1. There we have it. So x would be equal to 4 plus and minus something over 2 square root of, so that would be negative 4 squared would be 16, and then that would be plus 4 times, negative 4 times negative 7, 28, plus 28. So I get 4 plus and minus, and then we have over, so there we need to find the square root of that. So 16 plus 28, that give me 44, square root of 44 divided by 2. So we get 4 plus and minus square root of 44 divided by 2. So I need to reduce this 44. Okay. 44 is really is 4 times 11. So I can write this as 4 plus and minus square root of 4 times square root of 11. So part of 44 is perfectly squared, which is this radical 4, which I can turn into 2. So x would be equal to 4 plus and minus 2 radical 11 over 2. Last thing you have to do is make sure that we can reduce this to its lowest term. Looks like each term is factor of 2. So you can divide each term by 2, or you can factor the 2 out at the top. That's another way to do it. And then divide this 2, or you could divide each term by 2, you get the same answer. So the answer should be 2 plus and minus radical 11. So would be one answer would be 2 plus radical 11. The other answer would be 2 minus radical 11. And looks like that we have 2 minus radical 11 and 2 plus radical 11. The A should be the correct answer over here. Okay, here we have an equation that involves the exponents being 2 over 3 and the other one is 1 over 3. We can solve this, we call it by substitution method. Actually, we use substitution method every time we see these two terms are square of one another. So if this were like x to the power of 4 and this was x to the power of 2, we could do substitution method. And if you look carefully, if I let x to the power of 1 over 3, which I'm going to call it anything I want, I'm going to call it w. That's what we call a substitution method. I'm going to substitute w for x to the power of 1/2. Why I'm doing this is because when I square both sides, then I would get the other term. See? W squared then would be equal to x to the power of 2 over 3. That's exactly what I have here. So now if I substitute for each of these values, its corresponding variable in terms of w, then this give me 3w minus 4, and this would give me just w squared. You see how I'm forcing this to be look like a second order equation that we all should familiar with solving that. So again, use a substitution method. We substitute another variable for this x to the power 1/3. We do that only because if I square this, I would get the other one. All right, so everybody should know how to solve this. If it's not factorable, you can use quadratic formula, but this looks like factorable. Let's go ahead and factor this. I get w, and then for 4, I can get 1 and 4. I want to get plus 3 out of that. So if I make 4 plus and 1 minus, I get plus 3. And then don't forget, you always want to check and see my -4 plus times plus 4. It give you this term here, -4, which it does. Okay, so now I can solve for w. W minus 1 equal to 0. W would be equal to 1, or w plus 4 is equal to 0. So w is equal to -4. Now, we're not solving for w, we're solving for x. So I have to go back to my original assumption, which was w is equal to x to the power of 1/3, and then solve for x using these two cases that I have. If w is equal to 1, then 1 is equal to x to the power 1/3, and then solve for x. If w is equal to -4, then -4 is equal to x to the power of 1/3. And we can solve this by raising both sides of the equation to the power of 3 here. So if I raise this to the power of 3 and raise this to the power of 3, then I can eliminate those exponents there. So I can isolate x. So there we have x is equal to 1 cubed, which is 1. That's one solution. Or we do the same thing here. We go ahead and raise both sides of the equation to the power of 3. And then you would get x on the right-hand side is equal to -4 to the power of 3, right? So it's like you're multiplying -4 by itself 3 times, 4 times 4 times 4. That gives you 64. That gives you -64. So that's my next solution. So looks like -64 and 1, which is A, is the correct answer here. Okay, here we have an equation to solve for x, and this looks like is a good candidate to solve by substitution method. You could expand this binomial, by the way, and distribute the 6 and distribute the 11 and combine like terms and get into standard form and then factor it. That would be a lot of work. The shortcut would be to let x minus 5 be equal to another variable like w. We call it substitution method, because if I square both sides, I can get the other term. All right, so this would be 6w squared plus 11w plus 3 equal to 0. See how I forced this to be a second order equation now using the substitution method. So the only thing is I have to see if I can factor this. If you cannot factor this, I can use the quadratic formula. I'm going to pause the session here. For those of you watching this later at home, now is a good time also to pause and see if we can factor this first and then see what we get for w, and then solve for x. So those of you following this live with me now, I want to see if you can tell me how to factor this. All right, so let's see how to factor this. We can use trial and error method. Open two parentheses here and let it equal to 0. For w squared, that's obvious, it's w and w. For 6, the possibility would be 1 and 6 and 2 and 3. Usually 1 and 6 are the one I'm going to try first. I'm going to put 2 here and 3 here. And for 3 is only one possibility. Now, if I put 1 here and 3 here, you notice that it's not going to work out, because if I multiply the 2 closest term and 2 furthest term, I get 3w, and then here I get 6w. 3 and 6, I cannot make 11 out of that. But if I move this around, that's what I call trial and error method. If I move this 1 over here and 3 over here and dash, that could be the right combination. Because now if I multiply the closest term together, what do I get? I get 9w, and the two furthest will be 2w. And yes, I can make 11w out of that, and if all of these are positive. So that's how you factor this. So you get 2w plus 3 equal to 0. I can solve for w by subtracting 3 from both sides of the equation and divide both sides by 2. I get negative 3 over 2 here. Okay, so that's one solution would be negative 3 over 2. Or I have 3w plus 1 equal to 0. 3w is equal to negative 1. W is equal to negative 1 over 3. These are my w's, but they're not asking to solve for w, they're asking to solve for x. So what you need to do is to go ahead and go back to your original assumption. We said w is equal to x minus 5. So there are two cases we have to check here. Case number 1 is when I have w is equal to minus 3 over 2. Case number 2, when w is equal to minus 1 over 3. All right, so if minus 3 over 2 equal to x minus 5, you have to solve this for x. That's 1. And then we also need to do the same thing for minus 1/3 is equal to x minus 5. We have to solve both of these. All right, that's not too hard. We can just simply add 5 to both sides of the equation. Minus 3 over 2 plus 5 over 1. The LCD is 2. So if I go ahead and multiply the top and bottom of this fraction by 2 over 2, then I get to have a same LCD as 2. So I get minus 3/2 plus 2 times of the 10 over 2. That's my x. Okay. And here I get negative 3 plus 10. They give me 7 over 2. That's one solution for x. Now the second one, I would go ahead and do the same thing. I'm going to go ahead and write x then equal to minus 1/3 plus 5 over 1. Here I need to multiply this by 3 over 3. Okay, so this would be minus 1 plus 15. Minus 1 plus 15 would be 14. That's good. It would be 14 plus 14 over 3. So that should be a correct answer. Okay, so here we're talking about the rationalizing the denominator, and then you need to know the conjugate of binomial. If I have a plus b, then its conjugate would be a minus b. So when I multiply a plus b by a minus b, that would be difference of a square. I get a squared minus b squared. If you recall, we did this, some of the problem here that was from the practice final exam, where we had two terms at the bottom of the fraction where we need to eliminate the radical. We don't care what we have at the top of the fraction, really. We only care about what we have at the bottom of the fraction. So this would be a good example right here. 1 over square root of 5 minus square root of 3. So in order to eliminate these two squares, I'll multiply by its conjugate. The conjugate of radical 5 minus radical 3 would be radical 5 plus radical 3. So if I multiply the binomial by its conjugate, you get the difference of a square. Your first term would be radical 5 square. Your second term would be radical 3 square. So radical 5 square gives you 5, because this radical 25 square would be, radical 25 is 5. Radical 3 square would be 9. Would be radical 9 squared, which is 3. So you see how I eliminate the radical by just simply multiply by its conjugate. Now some of this radical move to the top of the fraction, which we said is okay to have that. So you would get radical 5 plus radical 3 over 5 minus 2, which is equal to 2. So now this is how you rationalize the expression. Just to make sure everybody following me, for those of you watching this live, I'm going to go ahead and pause this part and see if everybody okay with me with this part before I move on. Okay, so looks like everybody okay so far. So let's take a look at this example. The first one, if I have 1 over square root of 3 plus square root of 6. Okay, so in order to rationalize this, I need to multiply the top and bottom of the fraction by the conjugate of what I have at the bottom of the fraction. Radical 3 plus radical 6, its conjugate would be radical 3 minus radical 6. So if I multiply binomial by its conjugate, you get difference of square. Radical 3 times radical 3 would be 3. Radical 6 times radical 6 would be 6. You see how I eliminate the radical at the bottom of the fraction. But some of this radical moves to the top of the fraction, which is okay. So you would get a negative 3 at the top. You can move this negative actually to top of the fraction if you like and distribute it, and you get this form here. Okay. Again, those of you watching this later at home, you can go then kind of hide these solutions and see if you can get it on your own before you look at the solutions. So the next one for part B, the conjugate of 2 radical 7x minus 3 would be 2 radical 7x plus 3. See how if I multiply that by its conjugate, you get difference of square again. And don't forget this 2 gets squared become 4. And this radical 7x becomes 7x. And 3 squared would be 9. So how I eliminate the radical altogether? And again, the top, I don't care. I just go ahead and multiply, distribute this 3. And whatever I get would be my numbers at the top. But you make sure that you reduce this if it's reducible. Next example, I have 2 minus radical 7. See, I can multiply the top and bottom fraction by its conjugate, which is 2 minus radical 7. 2 plus radical 7 is conjugate with 2 minus radical 7. So difference of the square would be 2 squared, which is 4. Radical 7 squared would be 7. I eliminate the radical. The top, I just multiply term by term and combine like terms. And whatever I get, that would be at the top of the fraction. For part D, the conjugate of 5 minus radical 2 would be 5 plus radical 2. So this is how you multiply the top and bottom by its conjugate. You get 5 squared is 25, radical 2 squared is 2, which is radical 4, which is 2. And then again, top, we would get some radical, which is okay. Last two examples here, radical a minus radical b, multiplied by its conjugate, radical a plus radical b, they give you a minus b, right? Radical a squared would be a, radical b squared would be, again, the top, you just multiply term by term and leave it as that. And last one, radical 3 minus x, this conjugate would be radical 3 plus x, and then again we get 3 minus x squared, and that's how you would rationalize the denominator. Okay, here we talked about how to solve equations involving radical, if you recall, and one of the problems from our practice final exam was like that. Now we have some steps here. You may want to write this down and pause the session at this point. Step number 1 is to isolate the radical. That's the first thing we want to do. We want to make sure that radical is in one side of the equation, and sometimes it's not possible. Then you have to do this process twice. So if you can isolate a radical, you want to move a radical in one side of the equation and all the numbers or the variable you have to the other side. And the next step is to raise both sides of the equation to the power of 2 so you can eliminate the radical, and then simply solve for it, and at the end you have to check the answer. So these are good examples here in addition to what we did before. If I have radical 2x plus 1 equal to 5, it would be a good idea to all this problem. I'm going to go over it with the solution. Just hide the solution for yourself and do it yourself. See if you can get these answers. So this is already isolated, so I don't have to worry about that. If I raise both sides of the equation to the power of 2, I can eliminate the radical, and then from there on you just have to solve for x. You have to check the answer, of course. This other example, same thing, already isolated. The difference here is on the right-hand side, you get x minus 1. So don't forget, you have to square both sides, not each term. So here, it requires you to know how to expand this side here. So let me go ahead and write on this one also. So refresh on that part. Okay, so this side here is like a. Okay, I didn't mean to jump like that. So if I have okay, let's see, eraser, pen. I'm not sure why it's doing that. Sorry, guys. Okay, let's find my pen again. Color, black. Okay. Yeah, here you go. All right. A, if I have a minus b squared, that would be a squared minus 2ab plus b squared. That's what you're going to use. Okay. So in this case, x minus 1, if I have x minus 1 squared, that would be x squared minus 2x plus 1. That's how we get this right here. So once we get to this form, move everything to one side of the equation, and then you would simply solve for x. Again, don't forget, you need to check the answer for all these. Make sure these are checking out. That's the correct answer for all that. Let's go move down to here. So if you check the answer for these, the first one check out. 12 is good. The second one, only 8 is good. And 0 is not going to be a correct answer, because if I substitute 0 for each x, it's not going to work. It's not going to be equal. So you always have to check your answer at the end. It's really important. Okay, so let's go over this other example. And these are number 1 and 2. Okay, here we have the radical already isolated. So in this case, you just have to square both sides. You square both sides, and that's a simple one. You get q is equal to 2, and then when you check the answer, it checks out. This other one, we have to, this is already isolated also. You just raise both sides of the equation to the power of 2. Now here you have to be careful with those formula again. A squared minus 2ab plus b squared. And then you move everything to one side of the equation. You factor it, and then you solve for it. Now, if it's not factorable, you have to use the quadratic formula. And then this one, again, the first one checks out. 10 it's indeed a correct answer. However, 4 is not going to work. So 4 is not a solution. You could have a cube root. If you have a cube root, you have to still isolate the radical, divide both sides by 2, and then you can raise both of the equation to power of 3, because that's a cube root. So in this case, it didn't bother with 2 at all. Just go ahead and you could divide both sides by 2 first, and then raise to the power of 3. Either way would be fine. And then once you eliminate the radical, then you can solve for x and check the answer. Again, all these you should really sit down and try to do it on your own and check the answer with the way I'm showing you. This last one, this is the root is 4. So it doesn't have to be square root. It could be a higher root. In this case, you have to raise both sides of the equation to the power of 4, because the index here is 4. And we can stop right here, because if the index is 4 and you get a negative number, you can say you cannot have negative here. If the root is even, you cannot have negative numbers. Even if you raise both sides of the equation to the power of 4 and you solve that whatever answer for x, when you plug it back in here, it's not going to work. So it would be kind of like a shortcut. If the root is even and then you get a negative number here, you can conclude from there that there's no solution for that one. Okay. The higher root would be the same. So we just, in this case, we can isolate and raise both of the equation to the power of 3 and solve it accordingly. This one would be a good example here. We can, this example number 5, we cannot isolate the radical, because if I move the radical 2 minus x to the right, then it would be getting involved with this other term. So what you need to do in this case, you have to do it twice. So this would be a good example to do it on your own and kind of check your answer. When you raise both of the equation to the power of 2, the term 2ab still contains radical. So you need to isolate again and then square it one more time. So you have to do it twice and then check the answer. So this would be a good one. I never said anything like that in the final exam, but you never know. You should work on this one and know how to do this type of problem as well. This is another one that you cannot isolate the radical. When you cannot isolate the radical, at least move one of them to the other side, raise both of the equation to the power of 2, then isolate the radical, and then raise it to the power of 2 again. So you have to do it twice. And of course, check the answer on those. So the last ones are a little bit more involved because you need to do this process twice, but I just wanted to show you that so you know how it's been done. Again, most likely for the final exam, you're going to see the one that you can isolate like we did earlier and quickly find the answer, but you should really work on these as well and make sure you know how to do that.